I was discussing the need of testing the assumptions, why the assumptions are basically needed, why we need to test the assumptions. So I was discussing that we need to have valid inference, and in the presence of testing the regression assumptions, our inferences would be considered valid, our inferences would be considered true and consistent. Uh, the second point that I was discussing is the bias in coefficient estimate. If we have ignored uh, the assumptions testing like linearity, independence, or absence of multicollinearity, or they are simply violated, our coefficient estimates would be considered as biased. So the coefficient estimate may be biased, meaning they do not accurately reflect the true relationship between the variables. The third valid consideration is efficiency of estimations. So basically, regression assumptions test whether whether our estimations are efficient or not. Violation of assumptions can reduce the efficiency of parameter estimates, making them less precise. Efficient estimate is crucial for obtaining accurate and reliable results. The fourth one is reliability of predictions, because sometimes we need to predict our dependent variable on the basis of independent variable. So whether our prediction is reliable or not, we need to test the regression assumptions. So regression models are often used for making prediction. Assumptions such as homoscedasticity and normality of residues are essential for ensuring that prediction intervals are reliable and accurate. The fifth one is model interpretation. If the assumptions are true, we can interpret the model in a standard way. Understanding the assumption helps in interpreting the model correctly. For example, the assumption of linearity implies that changes in the independent variable have a constant effect on the dependent variable. In the same way, there is a sixth consideration which basically explains that the model need to be generalized. So checking assumptions enhances the generalizability of your model. It means the model is applicable to the other domains, to the other context, or to the other populations if your assumptions are true. If the assumptions are violated or you may have ignored testing the assumptions, your model may not be generalizable to new or unseen data. If the assumptions hold, the model is more likely to generalize well to the other population or context. Then the seventh consideration is outlier and influential point detection. Assumption helps in identifying outlier and influential point that may have a substantial impact on the results. Addressing these points can improve the robustness of the model. Sometimes we may have some outliers or some extreme values in our data. So testing the assumptions can basically identify these outliers that may substantially impact our results. Then avoiding multicollinearity issues. Multicollinearity can make it challenging to determine the unique contribution of each predictors. Checking for multicollinearity helps ensure that independent variables are not too highly correlated. Basically, we need to have a correlation between independent and dependent variables. But sometimes independent variable may have highly and significantly correlated with each other. So we need to check whether they are correlated or not, and we can check it or we can verify it using multicollinearity. Then we may have building credibility. Validating assumptions add credibility to your analysis. It demonstrates a rigorous and systematic approach to modeling, increasing confidence in the reliability of your findings. It means if you have verified your assumptions, your results would be reliable, and you would be more confident in interpreting these results. Then the last one is ethical consideration. In research and data analysis, there is an ethical responsibility to conduct analysis that are methodologically sound. Reporting results without considering or checking assumptions can be misleading. So It is an ethical duty, it is a responsibility of data analyst and researcher to comply the regression assumptions before finalizing his or her results, and before generalizing these results and before making any inference that the regression assumptions are being tested. So these are the basic consideration. So what are the regression assumptions, and how can we differentiate between them? There are a total number of 8 regression assumptions. Normally, if you study some econometrics books or some statistical books, they would show you the first 5 assumptions because they are common in each type of data set. But regression assumption 6, 7, and 8 may be different in some sort of data sets. So you need to check whether which type of assumptions need to be met, and which type are not relevant to your data. So the first assumption is linearity. Linearity states there should be a linear relationship between dependent variable and independent variable. I will explain it after some parts of these slides. That what does it mean? How can we check these assumptions using SPSS? Then the second important assumption is normality. The residual or error should follow normal probability distribution. It means your data need to be normally distributed, especially the residual of your dependent variable should be normally distributed. Then there is another assumption, another important assumption, which states that the error of one observation should not be systematically related to the error of other observation. It means the error of two different observations should not be correlated with each other. So if the error of two different observations are correlated, the data would not be comply the assumptions of independence of error. So whenever your errors are not correlated with each other, we can say that assumptions of independence is met. Then there is a fourth assumption, which is multicollinearity assumption. It means that your independent variables should not be perfectly correlated with each other. So whenever your independent variables are perfectly correlated with each others, we may say this condition as a multicollinearity. Then there is a fifth assumption. It states that there should not be a significant outliers in the model. Outliers means the extreme values. Some values are above the range or below the range. They would be considered as a outlier. So there should be no significant outlier in the model or in the data. The sixth assumption is homoscedasticity. Homoscedasticity means the variance of the residual should be constant across all level of independent variables. It means whenever we compute the errors of different independent variables, the error should be constant. The error should be constant at all levels, because there are different steps of data, or there are different levels of the data, and we need to check that each level of data, at each level of data, or at each level of our independent variable, the residual should be constant. So if this assumptions is not same, or our data shows that the variance or residual is not constant across all level of independent variables, we may say that the condition is considered as heteroscedasticity. It means the violation of homoscedasticity. So whenever this assumption is violated, we may state that condition as a heteroscedasticity. Then there is another assumption which is known as auto or serial correlation. This assumption states that the residual are not perfectly correlated with each other. This assumption is basically checked using the time series data. So as our data is basically the survey based data, so we need not to check this assumption, but we need to have an idea what does auto correlation or serial correlation means, and how it is different from multicollinearity. In case of multicollinearity, the correlation between independent variable is assessed. If the correlation between independent variable is perfectly correlated, then we can say it is a multicollinearity. But when the residual are perfectly correlated with each other, in case of time series data, we may call it as a auto or serial correlation. So in case of multicollinearity, independent variables are there, while in case of auto or serial correlation, the residuals are there. Then there is a eighth assumption, which is endogeneity, which means that when one or more independent variable are correlated with the residuals. So you can say that it is a combination of multicollinearity and serial correlation. So whenever your independent variables are correlated with your error terms, we may call this situation as a endogeneity. One or more independent variable should not be correlated with residual. So it is the case of cross-sectional panel or survey data. So there are a total number of 8 assumptions of regressions, but we need to test the first 6 using SPSS because SPSS does not support the assumption number 7 and 8. They are basically specifically designed for secondary data analysis. Sir, I want to know how to interpret logistic regression. Basically, um I have planned tomorrow session for different cases of regression where I would let you know how to interpret the logistic regression also. I will let you know the binary logistic and multinomial logistic. So the session is tomorrow for different cases of regression. So you will learn uh, the interpretation of logistic regression tomorrow. Can we proceed further? Because your question is related to Saturday session tomorrow. So we can proceed further. So these are the basic idea of assumptions of regression. Now we will consider uh, the much broader detail about the assumptions of regression. The first assumption was linearity between independent variables and dependent variables. So what do you mean by linearity? The relationship between the dependent variable and independent variable are assumed to be linear. This means that changes in the independent variable are associated with constant changes in the dependent variable. So whenever your dependent variable changes in the same proportion as the change in independent variable, we can say that linearity is there. So in case of linearity, the proportion of change in the independent variable and the dependent variable would be same. Uh, that is, there is a straight line relationship between the dependent variable and the set of independent variables. So whenever you depict the relationship between dependent and independent variable using that straight line, you can say the linearity is there. So linearity requires that your independent variable and your dependent variable would have a relationship using a straight line. So linearity means that the relationship between two variables, IV and DV, need to follow some pattern using a straight line. It may have been increasing or decreasing, upward or downward pattern. So there are three different categories of linearity. It may be positive linear relationship, it may be negative linear relationship. When the relationship is in the form that it is increasing from left to right, it would be considered as a increasing or positive linear relationship, and you can see that it is depicted by a straight line. So it is an increasing relationship where you can take your dependent variable on the vertical axis and your independent variable on the horizontal axis. So whenever your dependent variable changes in the same proportion as your independent variable changes, and we depict this relationship using a straight line. We may say it a linear relationship. So you can see here a positive one, and in case when the relationship is falling down from the left to right side, we may consider it a negative relationship, and sometimes the relation may be weak linear relationship that you can see in the plot 3. So in a linear relationship, the change in one variable is proportional to the change in another variable. So whenever the change in one variable or your independent variable is proportional to the change in the dependent variable, we may consider it as a linear relationship. So example of the linear relationship would be the relationship between hours of the study and the exam score. So whenever you increases the hours of the study, your exams score may be increased. So assuming a linear correlation, if there is a constant increase in the study hours, there is a consistent increase in exam score. So so the linear relationships are stated in these ways. So, what if the relationship is non-linear? In non-linear relationship, the change in one variable is not proportional to the change in another variable. So, when the proportion of change is different in independent variable and dependent variable, we may consider it as a non-linear relationship. The graph of the relationship is a curve and it does not follow a straight line. You can see when you depict a relationship between your independent variable and your dependent variable, and the curve look like this. It is not a straight line. It looks like a parabola or a curved line, you can say. So whenever the relationship looks like a plot 4, it is considered as a non-linear relationship, and sometimes it is like a curved line. Uh, so it is considered as a monotonic relationship. It is also non-linear. So example of the non-linear or monotonic relationship includes the relationship between the amount of fertilizer applied to the plants and resulting plant growth. Initially, the adding more fertilizer may increase growth, but at some point, further increase may have diminishing returns. So, whenever the rate of change is different in both variables, it will become non-linear. So, what is the SPSS procedure? How can we assess the linearity of independent variable and dependent variable? To assess the linearity, you can create scatter plot of dependent variable against each independent variable. If the relationship appear linear or straight line, it supports the assumption. So you need to test your linearity using the scatter plot. So how can we apply the procedure? We need to go to the graph, then we select the chart builder, then we select the OK button, then from the appearing box, choose scattered plot or dot plot from gallery in the bottom left. Then you double click the first option, scattered plot, then drag your DV into y-axis and your IV into x-axis and click OK, and double click the output graph and select the reference line option, and then click the fit line. If this option is dim, it means there is non-linear relationship between IV and DV. So this is how we can test the linearity of the relationship. I have also included some screenshot. You remember that in the previous session I have shared with you some data sets. So the example number 1 from the same data set will be used for your consideration, where final marks, total marks, and percentage are taken as a dependent variable and GPA as an independent variable. And we can use the same example data for our learning about this example. So this is how we can apply or test the linearity of our data. You need to go to the graph and then you need to select the chart builder. Then you need to click OK from the next window. and then you need to select the scattered plot or dot plot from the lower left bottom side, and then you need to click on the first option or the first choice that was provided against scatter plot. After selecting it, you need to drag your dependent variable into y-axis and your independent variable into x-axis. So you need to drag your IV and DV as it was mentioned in the screenshot. And then you need to click OK. When you click the OK button, a graph like this will appear, and you can see that it is a scattered plot, and you can see there is a scattered of different points over here, but uh, we cannot decide whether it is a positive relationship or whether it is a negative relationship. So how can we justify whether there is a linearity of the relationship prevailing over here or not? So there is a way. You can double click the graph and you can go here. You can find a ribbon bar right below the menu bar. A ribbon bar will be appear where there is an option of reference line. You need to click this reference line, and after clicking it, you need to click a fit line that is also available in the third bar right after the ribbon bar. The predicted line will let you know whether your relationship is linear or not, or whether it is perfectly linear, or whether it is weakly linear, and so on. So you need to click first the reference line, which will show the average of your data, and then you need to click the predict line in order to check whether your relationship is positively linear, negatively linear, or weakly linear. And you will find the graph like this. The middle line that you are seeing from 1 to onward, and it is showing the R square linear is equal to 0.187. This is basically the reference line that will appear whenever you click on the reference line option in the ribbon bar. And the second line that you can see above the 80 in total marks, and it is going and crossing the reference line. This line is basically your prediction line, and it is showing that how much is your beta naught and beta 1. And this line basically indicates that there is a weak positive linearity between IV and DV, because the relationship is not very strong. There is a weak relationship between IV and DV. And how can you understand that there is a weak relationship? I have told you in some previous slides. This this is basically the previous slides. Here you can see that in case of perfect linear relationship, if your predicted line is looking like this, the first plot one, if your predicted line is looking like plot one, you can say perfect linear relationship, perfect positive linear relationship. And if your predicted line is looking like plot 2, you can say that you have a strong negative linear relationship. But if your predicted lines looking like this, or something different from your positive linear regression, you can consider it as a weak linear relationship. So in our case, our predicted line is showing as a weak linear relationship like this. Just a minute. Yes, this one. So it is showing that the predicted line is indicating a weak linear relationship. So how can we apply the process I have just shared with you, uh, the screenshots of my already done data? So you have the data set that I previously shared with you, from where you can open example one data, and I can demonstrate that how this procedure was applied, so that you can understand that how you can apply the whole procedure, and you can understand how you can check the linearity of your data. So it is very simple procedure. You just need to have your IV and DV, and you need to put it in your scattered diagram or scattered graph in order to have a view of scatter diagram. Then you can put your reference line and your predicted line to have a brief overview whether this relationship is linear or not. So this is how you can find out uh, your linear relationship. So just wait for a minute. It will open your data set, and I will let you know the whole procedure of analyzing the linearity of your data. So here is your file, your example number one data, which I shared with you in the previous session. So here you can see your example one data. You need to go to the variable side. You need to have a dependent variable and an independent variable. In our case, our GPA, the GPA is basically our independent variable, and final marks is our dependent variable, as I have explained over here. Just a minute. Yes, this one. I have told that final term marks, you can take final term marks as a dependent variable, or you can take total marks as a dependent variable, or you can also take the percentage as a dependent variable. So any of these three you can take as a dependent variable, and you can take GPA as an independent variable for this data set. So I am taking final marks as a dependent variable. So what is the procedure? You need to go to the graph. You need to click on chart builder. You need to click OK. When you click the OK button, a window like this will appear. You need to click from the left bottom side the scatter dot option, and then you need to double click on the scattered plot option, which is appearing uh, uh, as a first option. You need to double click this option, and it will show you a scattered plot, blank scattered plot. Uh, you have here the y-axis and the x-axis blank option, and you need to drag your dependent and independent variable here. So what is our independent variable? GPA is our independent variable. So we need to drag GPA over x-axis, and then we need to drag our dependent variable, which is final term marks, over y-axis. So when we have successfully dragged the independent and dependent variable, we need to click OK button. And when you click the OK button, you will see a picture like this. This is basically the scattered diagram, and we cannot interpret whether it is a positive linear relationship or whether it is negative linear relationship. For doing so, we need to double click this picture. When we double click this picture, it will appear like this, and you can see that there is an option of reference line in the menu, in the ribbon bar. Right after the menu bar, there is an option of adding a reference line. When you click this option, you will find a reference line, which is basically the average line. It is basically the average line of your data. So it still not indicate whether our data is positively linear, negatively linear, or not linear. So in order to find out whether there is a positive linearity, negative linearity, we need to have a predicted line, which you can find out in the third row. Uh, right after the ribbon bar. The first is the menu bar, the second is the ribbon bar, and the third is basically the additional ribbon bar. So you need to click on the fit line. So this is the option of fit line. When you click it, you will find another line, which is basically the line fit, and it indicates that there is a weak positive linearity between independent variable and dependent variable. So this is the way how can we basically find out whether our linearity assumption is met or not. So here we can conclude that the assumption of linearity is met. Our data is linear, our independent and our dependent variable is linear. So we need to put this into our you can say output file. So we can add the interpretation about it. You simply had to copy and paste over here. So we need to copy again. Just a minute. You just need to copy chart. Right click over here and you just need to copy the chart, and you just need to control V, and the chart will appear here, but it is looking very small. So there is another way you can copy it. Yes, you can go to the previous window. From here you can copy or copy as a image. You can also copy it as a image. This is more preferred way, so the image cannot be considered editable. So here you can put the figure one, linearity between IV, that is GPA, and final down. So how can we interpret it? We just write here the figure one will that there is a weak there is a weak linear relationship GPA and final term. The GPA increases, final term marks will also. How you can put your linear relationship, and you can also state the linear regression line, which is you can see over here. You can also state over here best fit is y is equal to 47.08 5.18 into x. X means your independent variable, which is GPA. So how can we interpret it? This is basically the prediction line. It means if we by one month, the total mark increase by 5.18. So this is how you can basically interpret your regression line and your linearity. So in our case, our DB and IV is basically positively and weakly linear. So our first assumption is met. How can we test the linear relationship between the data? So um, I would like to have you a short drill on the same example, example number one, but take total marks as a DV or percentage as a DV and take GPA as a ID. So some of you would take the total marks as a dependent variable and GPA as an independent variable, and some of you can take percentage as a dependent variable and GPA as an independent variable. So you have 5 minutes. You can apply this procedure in order to check the linearity of your data. So we may have 5 minutes for that purpose. In the meanwhile, if someone needs to ask anything with reference to linearity assumption, I can elaborate. Yes. If anyone having any question related to how we have basically estimated the linearity, or you may have any confusion regarding the concept of linearity, you may ask. We need to check six assumptions, basically linearity, and we have completed the first one. So you need to do practice on example data one, and you need to consider total marks as a dependent variable, or you may take the percentage as a dependent variable, and please check whether your relationship between total marks and GPA or percentage and GPA is linear or not, or it may be it positively linear, negatively linear, weak linear. So whatever the relationship is, please kindly estimate that relationship so that we can proceed further. So if there is no any further consideration, we may proceed further. Uh, After 2 minutes, the meeting will be ended, and you can join from the same link after 2 minutes. So within 2 minutes, kindly check whether your uh, total marks and GPA relationship is linear or not, so that we can proceed further, and so that I may be assured that you are learning today's session more effectively or not. Meanwhile, I would like to let you know there are some remedies if your linearity assumption is violated. What to do if your linearity assumption is violated? So, if your linearity assumption is violated, it means that uh, you could you could not be able to prove that there is a linear relationship between independent variable and dependent variable. Then what to do? What is the remedy? The first remedy is to transform the variable. If if you if your analysis indicate that there is no linear relationship between iv and dv, you can take the logarithm, you can take the square root, or you can take the reciprocal of your variable, like dv and it. You can use the SPSS to create new variable with these transformations. So these are the things you can do using your compose variable function. You can add interaction terms. Sometimes mediation or moderation could be added uh, to have a non-linear effect by multiplying iv by another variable. This would also make your data